One potential solution could involve developing new composites that could better endure such intense pressures. Some scientists have proposed materials like carbon nanotubes, which are incredibly strong and lightweight. However, even these have limitations, especially when faced with underwater corrosion and the constant motion of the ocean. If dealing with the crushing depths wasn't enough, the ocean floor itself presents its own set of challenges. While the English Channel Tunnel had a relatively flat seafloor to work with, the Atlantic Ocean is a completely different beast. Its floor is not smooth and flat, but jagged and uneven, with massive underwater mountain ranges and deep trenches. The topography is more akin to trying to dig through the Rocky Mountains than a flat landscape. The ocean floor is also not made of a uniform material. While parts of it are solid rock, others are soft, unstable sediments that are prone to shifting. Traditional tunneling methods, like those used in land-based tunnel construction, may not work here. Drilling or boring through these materials could be incredibly difficult and unpredictable. We would likely need to invent new tunneling technologies that have never been tested before. Technology that would need to withstand not just the geological conditions, but the dynamic, ever-changing nature of the ocean floor. Additionally, the Atlantic is a region of intense tectonic activity. The ocean sits at the convergence of several tectonic plates, and earthquakes are a real threat. In some places, the plates shift rapidly, causing massive underwater movements. This could make any tunnel we build prone to damage from earthquakes, shifting sediments, and even underwater landslides, not to mention massive underwater volcanoes as well. Keeping a tunnel intact in such a volatile environment would require cutting-edge technologies yet to be developed that could handle these dynamic forces. Let's now dive into the danger posed by seismic activity and ocean currents. The Atlantic Ocean lies along the boundary of several tectonic plates, and as a result, seismic activity in the region is pretty common. Areas like the Mid-Atlantic Ridge are home to active fault lines that regularly shift. Earthquakes could shake the tunnel structure, causing fractures, shifting it out of alignment, or even destroying entire sections. Even if we could build a tunnel resilient enough to withstand the tremors of a moderate earthquake, there's another massive problem: ocean currents. Ocean currents are incredibly powerful and can change direction or strength unexpectedly. These shifting currents could erode the tunnel structure over time. Corrosion from saltwater and erosion caused by these currents could cause the tunnel to slowly degrade. Maintaining the tunnel to ensure its structural integrity would be an ongoing challenge, and a major catastrophe could be waiting in the wings if natural forces ever act on the tunnel. The more extreme the conditions, the more vulnerable the tunnel becomes. A small failure in one section could lead to a cascade of damage that may be impossible to repair. Sending maintenance crews thousands of feet below the surface would be incredibly difficult and risky. Any failure could trap them miles under the ocean, making rescue efforts next to impossible. Then there's the logistical nightmare of maintaining a transatlantic tunnel. The Channel Tunnel is already a difficult tunnel to maintain, despite being located in relatively shallow waters. Any underwater tunnel requires regular inspections to check for cracks, corrosion, or any signs of weakness. Today, this maintenance is carried out by specialized teams using remotely operated vehicles or divers. But imagine doing this at depths of over 10,000 feet. The cost, complexity, and risks involved would be astronomical. To maintain a tunnel in such a harsh environment, we would need to deploy deep-sea robots, equipped with the latest technology and capable of navigating the tunnel and performing repairs. These robots would have to withstand the immense pressure, operate in low-light conditions, and communicate effectively with surface crews. The risk of malfunction would be high, and the consequences would be disastrous. If a crack appeared in the tunnel, it could take months or even years to make the necessary repairs. Flooding could become a serious concern, especially given the vastness of the ocean and the difficulty of detecting leaks or small structural failures. A malfunctioning section of the tunnel could cause a flood of water that would be almost impossible to fix in time. Even if we could overcome the geological, natural, and logistical challenges, there's one more hurdle: the cost. Developing the necessary technology and materials for such a project would cost billions, if not trillions of dollars. Tunnel boring machines are designed for relatively shallow constructions, and they would need to be completely re-engineered to handle the extreme depths of the Atlantic. The cost of developing new materials, robotics, and other technologies would dwarf the cost of building the tunnel itself. And once the tunnel was built, maintaining it would require ongoing investments in technology and personnel. Given the challenges, it's clear that no matter how much money you throw at the project, the cost and complexity would far outweigh the potential benefits. Even if the tunnel was constructed, we would still have to ask the question, would it even be sustainable? Air travel continues to improve, and faster trains are already in the works that could one day make transatlantic tunnels obsolete. The staggering costs of building and maintaining such a structure would likely never be recovered, and there's no guarantee that demand would ever justify its construction. From an environmental perspective, the ecological impact of such a massive construction project would be immense. Extracting materials from the ocean floor and the immense energy required to maintain the tunnel could have severe environmental consequences. With such overwhelming costs, risks, and challenges, it's clear why a transatlantic tunnel may forever remain just a dream. Yet, despite these overwhelming challenges, some bold thinkers have come up with creative ideas for making a transatlantic tunnel possible. Here are a few of the wildest proposals. One suggestion is a floating tunnel. This isn't your average bridge or tunnel, but rather an idea where the tunnel would float on the ocean, supported by giant pontoons or anchored to the seabed. In theory, it would avoid the pressure and geological challenges faced by traditional tunnels at extreme depths. Also, you don't have to worry about digging through the earth or rock at the bottom of the ocean. The idea of a floating structure being held in place over a massive stretch of water without it being dragged by currents seems unrealistic. Even with advanced technology, the tunnel would be subjected to forces from wind, waves, and storms, making it a sitting duck for natural disasters. Then there's the issue of corrosion. Salt water doesn't just sit there looking pretty. It eats away at metal. No matter how durable the pontoons are, over time they would erode, weakening the entire structure. Not to mention the wear and tear from constantly moving with the waves. The floating tunnel would need to be constantly repaired, and that doesn't sound like a sustainable solution for the long term. Next up is the more familiar idea of a traditional seafloor tunnel. In this proposal, engineers would tunnel deep into the ocean bed, carving through rock and sediment to create a stable pathway for cars, trains, and other forms of transportation. Sounds simple enough on paper, but the challenges are insane. A tunnel boring machine would face the most extreme conditions, and we're talking about a project that could stretch thousands of miles under some of the most challenging underwater terrains. TBMs are good at digging through softer material, but solid rock at the bottom of the ocean? That's a whole different story. The deeper the tunnel goes, the more specialized and expensive the equipment required. This would make the project not only astronomically expensive, but also incredibly slow and inefficient. Then, there would be the maintenance costs of keeping the tunnel operational. Now, let's shift over to something a little more futuristic. The Hyperloop, a vacuum-sealed tube extending all the way across the Atlantic Ocean. High-speed pods would travel at speeds up to 700 miles an hour, allowing you to go from New York to London in just about an hour. It's the stuff of science fiction, but for a time, it was also considered a real possibility. While the Hyperloop has seen some success on land in small-scale trials, the idea of scaling it up to span the Atlantic is simply mind-boggling. First off, maintaining a vacuum-sealed tube for thousands of miles across open ocean is not only technologically challenging, it's downright impossible with current engineering methods. For the Hyperloop to function, the tube needs to stay sealed. One tiny breach and the whole system could collapse. There's also the whole issue of pressure. Building a vacuum-sealed tube at that depth would cause it to collapse, not to mention the forces of constant shifting water currents. If the tube were placed too shallow, it would be exposed to ocean storms and hurricanes that could rip it apart. Also, the maintenance required to keep such a delicate system in perfect working condition. Tracking down leaks, repairing any damage, and ensuring that the system stays airtight over thousands of miles would be virtually impossible. Even though the idea of crossing the Atlantic at lightning speed sounds incredible, the cost of building such a system would be out of this world. Add to that the maintenance costs, and it becomes clear that the Hyperloop across the ocean is more of a pipe dream than a feasible future. So why won't any of these ideas work? Well, it all boils down to a few key reasons: scale, environment, and cost. First, the scale of these projects is enormous. A transatlantic tunnel, Hyperloop, or floating tunnel would stretch across thousands of miles of open ocean, presenting logistical and engineering challenges on a scale that we've never seen before. Creating and maintaining a structure of this size requires cutting-edge technology, vast resources, and an insane amount of manpower. And that's just for the construction. After it's built, maintaining it would require near constant oversight and repairs. Second, the environment presents a host of problems. The ocean is constantly shifting. Currents, storms, earthquakes, and even minor changes in temperature can all affect the stability of a structure in the water. Saltwater corrosion is a constant threat, and even the toughest materials will wear down over time. A tunnel, Hyperloop, or floating structure would be at constant risk from these forces, and no matter how advanced the technology, it would be difficult to keep things running smoothly. Even with unlimited resources, the sheer financial burden of these projects would be unimaginable. The technology required is currently non-existent, and the ongoing costs for maintenance and repairs would drain any budget in no time. Simply put, these ideas are too expensive, too complicated, and just too risky to be feasible. In the distant future, it's possible that advancements in technology could make a transatlantic tunnel a reality. Innovations in AI-driven construction and ultra-strong materials could allow for the creation of structures that withstand the extreme conditions of the ocean. AI might be able to manage the complex task of digging through the ocean floor, while new materials could handle the pressure and forces deep underwater. But we're not there yet. Today, the ocean floor remains an incredibly challenging and dangerous environment for any construction. Even the most advanced materials and machines would struggle to cope with the immense depth and complexity of such a project. So, for now, the fastest and most reliable way to cross the Atlantic is still by plane. Even with rapid advancements in technology, a transatlantic tunnel is more science fiction than reality. It would require billions of dollars and decades of development, if not centuries. Until teleportation becomes a thing, a transatlantic tunnel will likely remain a distant dream. Airplanes will continue to be our best bet for crossing the Atlantic quickly, with the promise of a tunnel only being a possibility in the far, far future. Thanks for joining me today. I hope you enjoyed the video, and if you want to see more videos like this, then please consider subscribing and turn on notifications. Really does make a difference. Thanks again, and I'll see you next time.